Okay, so in this video we're going to do some work here with right triangles, and whether it's solving a right triangle or trying to set up right triangle trig ratios, it's often helpful to recall the acronym Sohcahtoa, which gives us the ratio of sides for a right triangle where our three main trig functions, sine, cosine, and tangent, will be equivalent to when applied to an angle. Sine of an angle for a right triangle is equal to opposite divided by hypotenuse. Cosine is equal to adjacent over hypotenuse, and tangent is equal to opposite over adjacent. Now, our reciprocal trig functions are as follows. Cosecant is the reciprocal of sine, so I flip sine's ratio. Secant is the reciprocal of cosine, so that means flip cosine's ratio, and cotangent is the reciprocal of tangent, so you would flip tangent's ratio. Now, when it comes to solving triangles, we're going to stick with sine and cosine and tangent. There's the reciprocal trig functions we really do not use to solve for right triangles. They're mainly for looking and analyzing their trig functions. So let's look here at this first problem here on the left-hand side. And basically what we want to do is we just want to see if I knew what theta was. I don't really want to solve for it, but if I did know what theta was, what would be the value of all six of these trig functions? Well, I may as well go ahead and start and try to find a third missing side. And so we have the 16 is the hypotenuse here, and to find the missing side, we'd use Pythagorean's theorem. A squared plus b squared is equal to c squared. So we have 11 squared plus the other leg squared would equal 16 squared. And I would need to solve for b, and we would wind up getting b squared to equal 135. And I'd take the square root of that. The square root of 135 would make 3 roots of 15. And so our missing side here would be 3 roots of 15. Now, it is often helpful for some to label the two other sides. See, the hypotenuse is always across from the 90, so I should never get that one messed up. The other side that touches the angle is considered the adjacent side, and the remaining third side would be opposite. And we do our ratio of sides. So cosine would be adjacent over hypotenuse, so 11 over 16. Sine would be opposite over hypotenuse, so 3 roots of 15 divided by 16. Tangent would be opposite over adjacent, so 3 roots of 15 over 11. And now we get to our reciprocal trig functions. So secant, flip cosine, so it'll be 16 over 11. Cosecant, flip sine, so 16 divided by 3 roots of 15. And cotangent, flip tangent, 11 divided by 3 roots of 15. And I'm not going to worry about rationalizing those denominators. Now let's look at an example. It's just similar but different approach. So here I give you the value of a trig function, and so basically it's ratio, and I want you to determine the values of the remaining 5 trig functions based on the fact that in this one, cosecant of theta, whatever theta is 17 divided by 15. Now, I can create a right triangle based on that ratio. And so I got my 90. I'm going to put theta here, and I'm going to label my sides hypotenuse, opposite, adjacent. Now, cosecant, being the reciprocal of sine, means that I have hypotenuse divided by opposite will produce that ratio. Well, I'm going to let the 17 go where the hypotenuse is. 15 goes where the opposite side is. And then I just have to solve for the adjacent side. So that takes us back to Pythagorean's theorem. A squared plus b squared is equal to c squared. All right, so I have 15 squared plus b squared is equal to 17 squared. And so 289 minus 225. B squared is equal to 64. B is 8. So my adjacent side is going to be 8. And then we would fill in our trig ratio. So cosine would be adjacent over hypotenuse, so 8 divided by 17. Sine will be opposite over hypotenuse, and technically I could have got sine right out of the gate by doing the reciprocal of cosecant. Tangent, opposite over adjacent. Secant, hypotenuse over adjacent, or flip cosine, 17 over 8. And cotangent be adjacent over opposite, or flip tangent. All right, so that's right triangle trig ratios right there. Now, let's work at solving right triangles. Now, remember, when it comes to solving right triangles, we are going to use sine, cosine, and tangent to solve. Those are the more common ones to be using. So let's look here at the problem on the left-hand side. So our goal is to solve for x. So what you would do in this kind of problem is you would look at the information that's provided, and I'm given this 37-degree angle. And relative to the angle, 12 is opposite, x is hypotenuse. So I'd go find the trig ratio that involves opposite and hypotenuse in terms of our solving trig functions, which would be sine, cosine, or tangent. That would be sine. Sine deals with opposite over hypotenuse. So sine of an angle is equal to opposite divided by hypotenuse, which gives us sine of 37 is equal to 12 divided by x. Now to solve for x from here, so I'm going to come up this way. I'd have to multiply both sides by x to get x out of the denominator. So I have x times sine of 37 is equal to 12. And then I divide by sine of 37. And then I'd go try to get my answer. Now remember here, your calculator needs to be in degrees because our angle measure is in degrees. And usually when we're working with triangles, they are. And so that way we get the correct answer. And we should get, if you type it into your calculator, we should get x is equal to approximately 19.94. All right, let's look at this one. So I look at the triangle that's given and the information that we have. All right, so we're given that we have a 20.5 degree angle. Relative to this angle, x would be adjacent, 10 would be hypotenuse. So using those two sides and that one angle, we'd refer back to Sohcahtoa. And adjacent and hypotenuse would be cosine. So cosine, when applied to an angle in a right triangle, is equivalent to adjacent over hypotenuse. So cosine of 20.5 would equal x divided by 10. And then to solve for x, we multiply both sides by 10, and that would give us 10 times cosine of 20.5 to be x. And we type that into our calculator, and we would get 9.367 to be x. All right, now let's look at solving for an angle. So I would take a similar approach, all right? So we want to find theta here, and we look at the information that's given. 3 is opposite, 5 is adjacent. And so to pick my trig function to use to solve the right triangle. Opposite and adjacent would be tangent. So tangent of an angle is equal to opposite divided by adjacent, which would give us tangent of theta would equal 3/5. Now, to solve from here, we have to take tangent off of theta. Now, the only way to remove a trig function is to apply its inverse. So I'm going to apply inverse tangent to both sides. So it'd be inverse tangent of theta equals inverse tangent of 3/5. Now, when I apply the inverse function of tangent to tangent itself, what it will do is it will take the tangent off the theta and leave me with just the inside here. So it would be theta equals inverse tangent of 3/5. And on your calculator, to get the inverse trig function, you press the second key and then hit the trig function you want to use. And so I do inverse tangent of 3/5. And we get 21.801 degrees. All right, let's look at one more of these right triangles here, where it says solve for all missing parts. Now, the way you approach this is you go find the easiest thing there is to get first. And anytime I'm given an angle, in fact, I'm given two angles here because I know that that corner down there is 90. I'm going to go find angle B first. So angle B, all three angles in a triangle should add up to equal 180. So I'm going to subtract from 180 to 90 and to 34. And that's going to give me angle B. And that's going to give me 56 degrees. So I know that angle B is 56 degrees. So I have that. Now, I take a pick as to what I want to solve for next. Well, doesn't really matter. I'm going to say, let's solve for side B, which is the side across from angle B. And to do that, I'm going to use the 34, the 10, and the 10. So the 10 will be opposite, and the B would be adjacent, and I'm going to use tangent. So tangent of 34 degrees is equal to opposite 10 divided by B, and I'm going to solve for B. So I'd multiply B to the other side, so that way it's out of the denominator, I can solve for it. And then I would divide by tangent, so B would equal 10 divided by tangent of 34. And I would get B. So side B, in this case, is going to equal 12.49. Or actually 12.349. And now that I have B, I would go find the missing third side here, which would be side C. Now, I could continue to do a trig function and go get that side, but I could also revert back to Pythagorean's theorem because I know 2 out of the 3 sides here. And say, all right, well, so my hypotenuse, I'm going to square the two legs, so 10 squared plus 12.349 squared is equal to C squared. And solve for C. And so I do add the 10 squared to 12.349 squared, get that sum, take the square root, and we get C to equal 15.89. All right, so that's using our right triangle trig ratios to solve triangles and determining the values of all 6 trig functions using right triangles as well.